Imagine you are floating in the dim red glow of your capsule, 6 months into the longest journey any human has ever attempted. Mars hangs in the blackness ahead like a rusted coin, growing larger by the hour, its ancient canyons and towering volcanoes painted in blood orange light. You press your palm against the cold viewport, heart steady for the first time since Earth faded to a pale blue dot. This is it, the moment every astronaut dreams of. You are about to become the first human to touch another world. But something is wrong. A soft chime turns into a shriek. The ship jolts hard enough to slam your helmet against the bulkhead. Red strobes flood the cabin. The autopilot voice, calm, mechanical, merciless, cuts through the static. Trajectory deviation detected. Impact probability in 7 minutes, 93%. Your stomach drops into freefall. You're not gliding toward a gentle touchdown. You're screaming toward Mars at 20,000 miles an hour, and the planet has already decided it doesn't want you. Mars looked so peaceful from a million miles away. Now it feels like it's lunging. But here's the problem. The danger didn't start when the alarms went off. It started the moment you left Earth's magnetic cradle. And it has been killing you slowly, invisibly, for every single second of the voyage. You remember the briefings. The doctors called it the invisible storm. Galactic cosmic rays, high-energy particles born in the depths of distant stars, have been ripping through your hull like invisible bullets. No atmosphere, no magnetic field to deflect them. Just you, our thin aluminum walls, and a constant drizzle of radiation that no spacesuit can stop. Every day out here, your cells took another hit. DNA, strands snapping like dry twigs. By month 3, your bone marrow was whispering warnings your blood test tried to ignore. But it gets worse. Solar flares. The sun doesn't warn you. One quiet afternoon, the radiation sensors spiked so hard the alarms couldn't keep up. You and your crewmates dove into the tiny storm shelter, a polyethylene box the size of a coffin, while the sun belched 1 billion tons of plasma straight at you. For 18 hours, you floated in the dark, listening to the ship creak and your own heartbeat thunder in your ears. When it ended, the dosimeter on your chest read numbers that would have grounded any astronaut back in the Apollo days. The doctors on Earth called it within acceptable limits. Acceptable for what? For a corpse that still breathes? You told yourself the risks were worth it. Humanity needs this. You need this. But now, with Mars filling half the sky, the truth feels heavier than the ship itself. The universe has been trying to kill you since the day you launched, and it has not stopped for a single second. You fire the attitude thrusters to correct course. The ship groans like an old man waking up angry. Outside, the first faint wisps of Mars' atmosphere begin to kiss the heat shield. Friction builds. A dull orange glow appears at the edges of your window. You're still 40 miles above the surface, moving faster than a rifle bullet, and the planet is just beginning to show its teeth. This is where scale becomes physics. A Mars is small, half the diameter of Earth, 1/3 the gravity. You thought that would make landing easier. The engineers promised it would. They were wrong, because small also means weak gravity, which means you never really slow down the way you do on Earth. You slam into its atmosphere at hypersonic speeds with almost no cushion. The heat shield is already glowing cherry red, then white hot, then the color of the sun itself. Plasma shears off in screaming sheets. The temperature outside is 4,000 degrees Fahrenheit. Inside, your suit's cooling system whines like it's about to die. Your body is pressed back into the seat with forces that feel like a giant's hand trying to shove your organs through your spine. 4 Gs. 5, 6. The world narrows to a red tunnel. You can't breathe. You can't scream. All you can do is watch the numbers on the console climb while the ship shudders so violently it feels like the bolts are about to shear. But here's the problem. Mars's atmosphere is only 1% as thick as Earth's. It's barely there. On Earth, a capsule would slow naturally, parachute, glide. Here, the air is too thin to break you fast enough and too thick to ignore. You're caught in the worst possible middle. The heat shield is shedding layers like burning skin. If it fails now, if even one microscopic crack opens, you will flash vaporize before you can finish your next breath. The parachute deploys with a cannon shot bang. For one heartbeat, you feel relief. Then the sensors scream again. The chute is inflating, but it's not slowing you enough. You are still supersonic. The ground is rushing up. Valles Marineris yawning like a black wound. Olympus Mons looming like a god that doesn't care. The sky crane engines are supposed to fire next, lowering you on cables like a spider on silk. But the computer is hesitating. Wind shear from an unexpected dust devil is throwing you off course by kilometers. And this is where things change. You realize, in the calmest, coldest part of your mind, that every successful Mars landing so far has been a miracle wrapped in luck. Remember the Mars Climate Orbiter in 1999? NASA's pride and joy. A navigation error, metric versus imperial units, sent it plunging straight into the atmosphere at the wrong angle. It burned up in seconds, a silent fireball no one on Earth could stop. Or Schiaparelli in 2016, the European lander that made it through entry, only for its parachute to fail and its retro rockets to cut out early. It slammed into the surface at 300 miles an hour, leaving nothing but a dark scar and a cloud of debris. Those were robots. Unfeeling chunks of metal. You are not. The ground is 2 miles away now and closing fast, but it gets worse. Dust. Everywhere. A global storm that brewed up 3 weeks ago has swallowed half the planet. The engineers on Earth told you it would clear. They were optimistic. Now the air is choked with particles so fine they float like smoke. Your radar is blind. Your optical cameras are painting the world in static. The landing site you trained for, the smooth plains of Jezero Crater, might as well be a minefield. Boulders the size of houses, and hidden under a haze thick enough to choke the sun. One wrong meter and your lander becomes a tombstone. You feel the first tremor of the descent engines lighting. The sky crane is trying. Cables unspool. For a moment, the violence eases. You are hovering, 30 feet above the surface, like a steel angel descending into hell. The dust below you is being blasted into a hurricane by your own rockets. Visibility drops to 0. The ground is invisible, but you can feel it, close enough to taste the iron in the air. Then the sensors flatline. The computer doesn't know where the surface is anymore. The altimeter is lying. The terrain relative navigation system is seeing ghosts in the dust. You hear the thrusters throttle up, then down, then up again in panicked confusion. The cables are still paying out. Your feet are inches from the ground now. But the ship doesn't know it. One more second of hesitation, and the engines will cut out too high. You will drop. Or the cables will snap, and you'll slam sideways. Either way, the result is the same. This is the hidden danger no simulation ever fully captured. Mars doesn't just have dust. It has electricity. The particles rubbing together in the storm generate massive static charges. Your lander is now a lightning rod drifting through a thundercloud made of sand. One discharge, and your electronics fry. One spark in the wrong fuel line, and the whole thing goes up like a Roman candle. We don't fully understand it. The probes that tried never lived long enough to explain why. You're so close. You can see the shadow of your lander on the swirling orange haze below. Your gloved hands are on the manual override. Sweat stings your eyes even though the suit is supposed to be climate controlled. Every muscle is locked. Every prayer you never believed in is screaming through your skull. But that's not even the worst part. The worst part is the realization that there is no safe scenario. Not one. You could have launched at a different time, taken a faster trajectory, carried twice the shielding, trained for twice as long. It wouldn't matter. The universe is not hostile. It is indifferent. And Mars is its perfect instrument, small enough to reach, deadly enough to punish every mistake. unknown enough to keep us guessing until the very last second. The cables go slack. You feel the lander legs touch down with a soft crunch. For one impossible heartbeat, the alarms fall silent. Then the ground gives way. A subsurface pocket of loose regolith, undetected and unguessable, collapses under your weight. The lander tilts. You're thrown sideways. Metal screams. Something vital ruptures. The cabin fills with the hiss of escaping air. Red dust pours in through a breach the size of your fist. Your suit inflates automatically, but the pressure drop is faster than the seals can compensate. Your vision tunnels. The last thing you see through the cracked visor is the Martian sky, beautiful, indifferent, eternal, turning black at the edges. You never quite landed. And in that final moment, as your consciousness slips away, the truth settles over you like the dust that will bury your ship within days. We are not explorers here. We are trespassers. The cosmos does not need us. It does not hate us. It simply continues, vast and cold and ancient, whether we survive the next 7 minutes or not. Mars didn't kill you when you touched its surface. It killed you the moment you believed you ever could. The screen fades to the red glow of a distant, unreachable world. A single line appears in white text. The universe was never meant for us. We just refuse to stop trying. And somewhere in the silence after the credits, you hear your own heartbeat, still racing, still wondering if next time will be different. But deep down, you already know the answer.